Hey everyone, in this video, I would like to cover PUMaC Combinatorics B round number 1, right? So let's read the question. I have a 2x4 grid of squares. How many ways can I shade at least one of the squares so that no two shaded squares share an edge? So I would say we got to perform some casework, right? So here we go. We need to draw a 2x4 squares. So we have 2x4 squares, and if I perform casework, I gotta say case number 1, what if I just color one of those squares, right? Just one square. So if I color one square, let's see what happens. Well, I think I can choose one out of those 8 squares, so we get 8 squares to color. Right, so what about case number 2? Case number 2 begins with coloring 2 squares. And if I need to color 2 squares, well, I think we need to use subcases. So for instance, what if I have row number 1? What if I have row number 1 plus 2? What if I have row number 2? So for an instance, if you think about this a little bit carefully, row number 1 contains certain pieces of 2 squares, not sharing any of those edges. So I would like to give certain number out here, 1, 2, and 3, 4, 5, and 6, 7, and 8. It could be something like 1, 3, right? It could be something like 1, 3, or it could be something like 1, 4, or it could be something like 2, 4. I would say, let's just try to erase this, and 2, 4. Now, what about row 1 and row 2? What if I give 1? I think we can perform all those cases. If I have 1, then I could have star. And if I get 2, and I can have star in the bottom part. And if I have 3, and I can get a star. And if I get 4, I can still get a star in the bottom. And those stars are going to be 1 out of 5, 6, 7, and 8. Now, if I have 1, this little star is going to be 6, 7, 8. The second star is going to be 5, 7, 8. The third star is going to be 5, 6, 8. And as you can check, if I hit 4, then I get 5, 6, 7 for the stars. So in each of those cases, I get 3 possibilities. So in other words, I need to multiply 4 by 3. We end up getting 12 cases. Now we get 3 cases on top. And I would say row number 2 containing all those 2 squares in row number 2 would be 5, 7, and 5, 8, and 6, 8. So we get 3 cases too, right? So 3 cases. So if I add it up, we get 18 cases in total. So 18 cases in total, right? So case number 3. What if I have 3 squares? Now 3 squares, using pigeonhole principle, each of those rows, at least one of the rows, I would say one of the rows will contain 2 squares. Now 2 squares shaded, 2 shaded squares. So it could be row 1 and row 2. So row 1 containing 2 and row 2 containing 1. So based upon each of those information, and of course we're going to multiply this up by 2 because I think it's going to be symmetric. So if I have 1, 3 and like 1, 3 and 1, 4 and 2, 4, so we get 3 cases, and each of those cases results in 2 possibilities, I would say. So we get 2 possibilities. So if I have 1, 3, then row 2 can be either 6 or 8. So if I have 1 and 4, then I get 6 or 7. If I have 2 and 4, then I end up getting 5 and 7, right? So we get 2 possibilities each for each of those row 1 information. So in other words, we get 3 times 2, but because of the symmetry, I need to multiply this out by 2 in order to get 12. Now, case number 4, which is going to be the last one, what if I have just all 4 squares to color? Now, if I color 4 squares, it's just going to be 1, 3, 6, 8. I would say 1, 3, and 6, and 8. And probably it's going to be something like 2, 4, and 5, 7. 2, 4. So let me erase this. 2, 4, and 5, and 7. That's 5 and 7. And nothing else would work. So we get 2 cases in those bottom parts as well. So case number 1, we get 8 cases. Case number 2, we get 18 cases. Case number 3 results in 12 cases. And, we get 2 cases down underneath. So if I add up all of these all together, I would say we get 40 cases to cover, and that shall be the answer.